Good afternoon. My name is Rashida, and we will be talking about the real-time parking detection system. So according to the INRIX parking research study released in 2017, the total cost of all parking paid in the U.S. was totaled to be $73 billion. Commuters on average spend 19 hours annually searching for parking, where that number can be 5 times greater in denser areas such as New York, where the average commuter spends 107 hours per year. Our team Dronix is working to develop a real-time parking detection system using machine learning-enabled image recognition that can use cameras that can be either stationary or mobile through drone technology. Our vision is that you can use basic cameras within both indoor and outdoor parking lots, register them with our application, and then be able to view available parking spots through an app on your phone or on the web, which would display a user-friendly map of all the parking spots. The system will also be able to tell you ahead of time whether a parking lot even has available parking, and also help reduce vehicle energy consumption, illegal parking, and also improve parking lot safety as a whole. My colleagues Edward, Sion, and Chris will talk more about the project architecture.
Thank you, Rashida. So our system begins with the camera nodes that you see here on our system diagram labeled in green, and these nodes can be either stationary fixed cameras or mobile nodes mounted on drones. And so these nodes will be placed in view of multiple parking spots, and then these nodes will periodically take images on a cycle, and then these images will be packaged up and then sent to an API on our server side, which will handle these requests and then do the analysis. And these requests will be handled over HTTP, and we anticipate on creating a RESTful API to handle it.
The server-side application will process and analyze the image taken by each node and make a determination of which spots are open and which are closed. And then this data will be updated to a persistent relational database where it holds the status of all spots in a parking lot.
The client-side application will be a hybrid application, which will allow both mobile and desktop users to be able to use their app on their device. The app will also receive another set of APIs exposed to the server-side application to get the parking map, the status for each of the spots, and then render this map for all the users. So our goal for Senior Design 2 is to develop a accurate and robust image recognition algorithm and a system which anyone can use and be able to integrate with. So we're open for questions.
So have you looked at other systems that are already on the market that do similar things?
Absolutely.
How is yours different?
Absolutely. So actually currently at UTD, if you notice the parking garages here, they actually have a very similar system that will monitor the number of spots available within their garages. And but they're very limited in what they can do. There even exists actually an app to check this data, but all it tells you is a count of the spots. It'll say like there's 50 green spots open, and that doesn't do much more than beyond that. For our system, we actually anticipate that you can actually look at a map and instantly know what floor, what section, and what spot is actually open within, say, like the past minute. The app will tell you that within the last 30 seconds, I've updated and checked that this spot is open. So it'll give you a real-time view of a parking lot. And there's an additional advantage that we have is that since we're just using cameras and we're just going to do image recognition, we can train our cameras to be good enough to where one camera can monitor up to 10 spots or 20 spots or however many spots that we can handle. And then you wouldn't no longer need a single IR sensor or one sensor per spot anymore. You also are no longer limited to just doing a parking garage. You can do an open parking spots or parking lots as well. You just need to install a camera. You can even use existing cameras that are CCTV or security cameras and leverage those existing frameworks and infrastructure to send to our app.
Yeah.
So you're thinking about doing a multi-level parking garage?
Yes, we think that you should be able to do that because all you would need is just a camera, which can either be moving or stationary. It could be running rounds and doing scouts of a scan.
Well, I've had cars that come about this far from the top of the, of the beams.
Right. So one note that one question you might have is like why exactly how do the drones work in this case? So the drones are really kind of a convenience factor for us because we want to be able to simulate and simulate multiple camera scenarios and camera view angles, and so it should be capable of handling arbitrary and generic heights and viewing angles. So with our drone, we can say like position it this high up, or this far back, or this far up, right over the spot, or a little far back to view multiple spots, and maybe at an angle or a tilt. And so we can train our AI algorithm with all these different images and all this different data. So hopefully it should be robust enough
But
to.
I'm worried about the drone colliding with cars going back and forth.
Right. Well, in that case, then we would say maybe in that instance we would program the drone to fly, at a certain level, or maybe in a parking garage it may be more suitable to just use the fixed camera. Or
Yeah, you
mounted
might
camera.
consider the drone to compute the proper fixed camera locations.
Mhm. Yes, we actually thought about that as well. So, so for our system design, we would think that a user would register their parking lot and then register individual nodes, and individual nodes own a parking section. So this parking section is numbered like 1 through 10 or whatever, and then this parking node will have a GPS location on it, and then we could program the drone to fly specifically at that location and then stay there, and then we could have extra metadata like only tilt this much or this down, or be at this altitude, and then that's how we can control individual nodes and being consistent and static.
What do you think is the most difficult part of your project?
I think the most difficult part for us will probably be doing the image recognition. We anticipate on using a machine learning library such as like MobileNet TensorFlow in order to do our image analysis, but that's probably going to be the most difficult part. We are going to start slow and steadily forward, improve our algorithm, so maybe it'll just work on one spot for now, but then we'll slowly scale up to more spots.
It seems to me that this project is very ambitious. Have you really thought about it? How much you can cover? Or
Yeah, so there is a lot of definitely a lot of work and material to cover, and a lot of yards to scale when it comes to the full stack application. So with the server side application, the client side application, but we anticipate that we should be able to do it. The client side application shouldn't be too much. We just need to host a set of APIs for the user side app or the front end to.
You might consider, by narrowing it by trying to just extend the, maybe the existing parking system here.
That's definitely
Add
something
that,
we thought about that.
Yeah.
Step on their shoulders, not on their feet.
Yeah, well, some of these parking lots, I think some other mentioned, is that there's not a lot of visual of the whole lot. I mean, the ceiling's really low. Put a camera there, you're not gonna be able to see. I guess you could put a drone, but that's kind of dangerous if somebody's wandering around in there. So,
There's one in Irving that's really low now.
yeah, right. So I think you have to deal with multiple cameras and somehow stitch them together, which is hard to do. But I mean, but it seems like you're going to do a lot, but it has like 100 slots per story, and then there's 4 or 5 stories. You're going to have a lot of cameras.
Yes. Yeah. We definitely thought about that.
All right.
Thank you.